The architectural proportions of St. Isaac's Cathedral in St. Petersburg suggest a standard of measurement that deviates fundamentally from the human scale, raising profound questions about the intended utility of its most monumental features. Standing before the massive portals of this structure, an observer is immediately confronted by a spatial paradox: doors that reach a height of 10 meters, adorned with bronze bas-reliefs of immense weight and complexity. While traditional art history classifies these dimensions as purely symbolic manifestations of imperial grandeur, a purely functional analysis reveals a series of engineering and ergonomic anomalies that challenge such a simplified explanation. Logic dictates that architecture is inherently tied to the biology and requirements of its inhabitants, yet, the physical reality of these portals appears to cater to a different set of biological parameters entirely. The three primary portals, the southern, northern, and western entrances, feature doors of staggering proportions. Each leaf of these doors is approximately 10 meters high and weighs roughly 10 to 20 tons, depending on the specific bronze composition and internal bracing. From a structural engineering perspective, the creation of a moving mechanism capable of supporting such mass while maintaining smooth rotation is a feat that stretches the limits of 19th-century metallurgy. The hinges must withstand incredible shear forces, and the alignment must be perfect to prevent the doors from jamming under their own weight. Reasoning logically, if the primary purpose of a door is to facilitate the passage of human beings, a height of 2 to 3 meters would be more than sufficient. Constructing an opening 5 times that height introduces significant complications, including massive heat loss in the frigid climate of St. Petersburg and the immense physical effort required to operate the mechanisms. An even more perplexing detail emerges upon closer inspection of the door hardware. The handles and locking mechanisms on several of these ancient entrances are positioned at a height that exceeds the reach of an average human being. In many instances, these handles are located 2 or even 3 meters above the ground. Standard ergonomic practice places handles at approximately 1 meter, aligning with the natural resting position of the human hand and the mechanical advantage required to pull or push a heavy object. To place a functional handle at a height where a person would require a ladder to reach it contradicts the basic principles of utilitarian design. It is possible to argue that these handles were intended for decorative purposes, yet their robust construction and mechanical integration into the door's internal locking systems suggests they were designed for frequent, forceful use. Consider the physics of leverage required to move a bronze leaf weighing several tons. If a human of average height attempts to push such a door, the force is applied at a point significantly lower than the door's center of mass, creating an inefficient distribution of energy and potential strain on the hinge assembly. However, if the force were applied at a height of 3 or 4 meters, the mechanical efficiency of the movement would change. This observation leads to a logical inquiry: was the architecture designed with a different physical stature in mind, or is there a forgotten technological reason for such a counterintuitive placement of manual controls? Perhaps the handles we see today are remnants of a system where the physical effort was distributed differently, or perhaps the users themselves possessed a different physical configuration. The internal volume of the cathedral further emphasizes this departure from human-centric scaling. The height of the ceiling, the placement of the windows, and the sheer verticality of the interior space create an environment where a human being feels diminished, almost incidental. While this is often attributed to the desire to evoke religious awe, one must consider the thermal dynamics of such a space. Heating a chamber of this magnitude in a northern latitude is a logistical nightmare. In the 19th century, the energy required to maintain a habitable temperature within a building featuring 10-meter-high doors would have been astronomical. Every time those doors are opened, the stratified warm air at the top of the dome would be displaced by a massive influx of cold air from the street. From a survival and resource management standpoint, these dimensions are profoundly illogical for a human population struggling against the harsh Russian winter. This leads to the analysis of the thresholds and the steps leading to these massive portals. In many classical structures of this period, the riser height of the stairs is often slightly higher than what is comfortable for a modern person, though this is frequently dismissed as a variation in historical standards. However, when combined with the 10-meter doors and the elevated handles, a pattern begins to emerge. This is not an isolated architectural flourish, it is a consistent system of proportions that appears to ignore the standard human frame. If we apply the principle of form follows function, we must ask what function is served by a door that could easily accommodate a creature 3 or 4 times the height of a man. Is it possible that the aesthetic we categorize as neoclassical or empire is actually a repurposed functional design from an era or a culture with different biological requirements? The materials used in the construction of these doors further deepen the mystery. The bronze is cast with such precision that the seams between various decorative elements are nearly invisible, suggesting a level of mastery over large-scale metal casting that remains difficult to replicate even with modern industrial techniques. The weight of the doors necessitates a foundation of immense stability. Beneath St. Isaac's Cathedral lie tens of thousands of wooden piles, driven into the marshy soil of the Neva Delta. The engineering effort required to stabilize the ground specifically to support these massive walls and their moving parts is unprecedented. If the goal was simply to build a beautiful church, lighter materials or smaller openings would have achieved the same visual effect with a fraction of the structural risk and cost. Some researchers suggest that the large doors were intended to allow for the passage of tall religious icons or ceremonial banners, yet even the most elaborate processions rarely exceed 4 or 5 meters in height. A 10-meter opening remains an architectural excess that defies a simple ceremonial explanation. Furthermore, the thickness of the walls, often reaching several meters, suggests a need for extreme structural durability, far beyond what is necessary to support a roof. This level of over-engineering is typical of structures meant to withstand immense external pressures or to support weights far greater than those officially recorded in historical documents. When observing the handles again, one must consider the mechanical resistance. A handle placed at 3 meters height is not merely difficult to reach, it is functionally useless for a human being unless that person is standing on a platform. If we assume the builders were logical and efficient, we must conclude that either the floor level was originally different, or the individuals operating these doors were significantly taller than we are today. The idea of a giant stature is often relegated to the realm of mythology, yet the physical evidence of the architecture remains, cast in bronze and carved in granite, standing as a silent witness to a logic we can no longer fully grasp. The mathematical consistency of these, oversized, features suggests a deliberate system. It is not merely one door or one handle, it is an entire urban landscape in St. Petersburg, and indeed in other world capitals, that exhibits these characteristics. The Winter Palace, the Hermitage, and various cathedrals across Europe all feature these heroic proportions. If we analyze the force required to turn a key in a lock that is scaled to a 10-meter door, we find that the torque required would likely snap a standard human-sized key. Consequently, the keys for these locks are often massive, heavy objects that require 2 hands to manipulate. Every aspect of the interaction between the user and the building is strained, as if the human is an intruder in a space designed for a larger, more powerful entity. Mathematical modeling of the cathedral's acoustics also reveals interesting anomalies. A space designed for human speech usually requires specific dampening and reflective surfaces to ensure clarity. However, the cavernous interior of St. Isaac's creates a reverberation time that makes normal conversation difficult, yet may have been perfectly suited for different frequencies or volumes of sound. Could the architecture be a resonant chamber designed for a voice with a much larger lung capacity? When we consider the physics of sound, the size of a resonant cavity is directly related to the wavelength of the sounds it is intended to amplify or contain. A person standing 6 feet tall produces a specific range of vocal frequencies. A being 12 feet tall would produce a much lower, more resonant frequency that would interact with the cathedral's volume in an entirely different manner. This brings us to the question of the builders. Historical records credit Auguste de Montferrand with the design and construction of the cathedral over a period of 40 years. While the archival documents are extensive, they often focus on the logistics of moving the massive granite columns rather than the underlying reason for the specific proportions of the portals. The official narrative suggests that the scale was chosen to reflect the power of the Russian Empire and its triumph over Napoleon. However, political symbolism rarely overrides the laws of physics and economics so completely. Building a 10-meter door that is impossible for a standard soldier or citizen to operate comfortably is a curious way to celebrate human victory. There is a version of history that suggests we are not looking at original designs, but at the remnants of a previous epoch of construction that was later adapted for use by modern humans. This would explain why we find human-sized doors frequently cut into the larger, giant-sized portals. In almost every massive door at St. Isaac's, there is a smaller, standard door built into the bronze leaf. This door within a door allows people to enter and exit without moving the 20-ton monolith. From a logical perspective, if the large doors were intended for human use, the smaller door would be unnecessary. If the large doors were purely decorative, they would not be mounted on functioning hinges with complex locks. The presence of the smaller door is a pragmatic admission that the larger portal is fundamentally unusable for daily human activity. As we examine the alignment of the handles once more, consider the biological possibility of a different human phenotype. If we assume the handle was placed at a comfortable chest height for the user would have to stand approximately 3 to 4 meters tall. While this contradicts our current understanding of human history, it aligns perfectly with the physical requirements of the architecture. The lever arms, the step heights, the line of sight through the windows, and the resistance of the door mechanisms all coalesce around this larger scale. Is it possible that the architecture is not monumental, but simply proportional to a different set of inhabitants whose existence has been erased from the formal records, leaving only these bronze and stone puzzles behind? Further complicating the matter is the precision of the stone cutting. The granite monoliths that form the porticos are polished to a mirror finish and fit together with tolerances that would be challenging to achieve today without computer-controlled machinery. This level of technical proficiency suggests that the builders possessed an understanding of materials and physics that was not merely primitive labor, but a highly advanced engineering tradition. If they were capable of such precision, their choice of 10-meter doors cannot be dismissed as an accidental excess. It was a calculated, deliberate decision based on a set of requirements that we are now trying to reconstruct through observation and logic. The thermal challenges mentioned earlier merit a more detailed physical analysis. In a space as large as St. Isaac's, the air pressure and temperature gradients create significant drafts. A 10-meter opening at ground level acts as a massive heat exchanger. For a society relying on wood or coal for heating, the energy cost of opening these doors would be catastrophic. Even today, with modern heating systems, the cathedral remains a difficult environment to regulate. The logic of the giant doors only holds if the occupants were either indifferent to the cold, or if the doors were rarely, if ever, opened by the people we see in the history books. Or perhaps, the climate at the time of their original conception was fundamentally different, rendering the thermal loss a non-factor. Wait until you look at the internal stairs leading to the attic and the dome. Here, the proportions shift again. In areas hidden from the public eye, where grandeur and imperial symbolism are no longer necessary, we find architectural choices that are equally baffling. Narrow passages that open into massive chambers, and stone steps that seem to vary in height for no apparent structural reason. It is as if the building is a composite of different design philosophies, or perhaps, a structure that has been modified multiple times to accommodate changing sizes of inhabitants. If we look at the hinges of the great western doors, we see that they are not merely large versions of standard hinges. They are complex mechanical joints designed to distribute the load across a wide surface area of the stone wall. The amount of friction generated by moving these doors would produce significant heat, and where if they were opened frequently. This suggests that the doors were either designed for a very specific, infrequent purpose, or that the builders had access to a method of friction reduction that we have yet to identify. Reasoning logically, a culture that could move and set 114-ton columns would have no trouble designing a door that a human could open, yet they chose to build one that requires the strength of several men, or one very large individual. As we move deeper into the analysis of the cathedral's interior, we find that the placement of the icons and the height of the altar screen, the iconostasis, also follow this elevated, logic. The primary visual focal points are often positioned far above the natural eye level of a standing human. To see the details of the upper tiers, one must crane their neck uncomfortably. Again, the standard explanation is looking up to heaven. But from a design standpoint, it is an inefficient way to display information or art to a target audience. Unless, of course, the target audience was taller, placing their eye level significantly higher than ours. The mystery deepens when we compare the exterior, giant, features with the cramped, almost claustrophobic service tunnels used by the workers. This contrast creates a dual reality within the same structure, a grand, oversized world for the masters, and a small, functional world for the servants. But even this does not explain the handles on the main doors. Even a servant must be able to open a door. If the handles are out of reach for the servant and the master alike, the design fails the most basic test of utility. Let us turn our attention to the metallurgical analysis of the bronze itself. The casting of 10-meter-tall panels without warping or significant air bubbles is a task that requires precise temperature control and a massive foundry capacity. The historical record states these were cast in several pieces and joined, but the seams are so expertly hidden that they appear as single, monolithic slabs. This level of craftsmanship suggests that the giants were not just large in stature, but possessed a highly sophisticated industrial base. The question then becomes, why would such an advanced civilization build everything on such a massive scale? In our own modern world, we strive for miniaturization and efficiency. A larger building requires more material, more energy, and more maintenance. The only logical reason to build big is if the users themselves are big. This brings us to a critical junction in our investigation. If we accept the architectural evidence at face value, we are forced to reconsider the history of the human form itself. If we reject the evidence as just art, we ignore the physical realities of engineering, ergonomics, and thermodynamics that govern all construction. The doors of St. Isaac's Cathedral are not merely entrances, they are anomalies in the fabric of our historical narrative. They stand as silent, bronze-clad questions, challenging us to look past the official labels and see the physical contradictions that remain hidden in plain sight. The placement of the push plates on these doors is perhaps the most damning piece of evidence. These plates, intended to protect the bronze from the oils and wear of human hands, are often found at heights that make them useless for the tourists and worshippers of today. Over decades of use, the patina of wear should be concentrated at the 1.2 to 1.5 meter mark. Instead, we see historical wear patterns and decorative focal points that suggest a different point of interaction. When you stand before these doors, you are not just looking at history, you are looking at a physical blueprint for a life form that we are told never existed. Consider the weight of the key once more. A key that weighs several kilograms is not a tool for a human hand, it is a burden. Yet these are the tools found in the archives of such cathedrals. The locks themselves are massive boxes of gears and levers, requiring significant physical force to engage. Every single point of contact between the human and the building is a struggle of scale. It is a world built for someone else, into which we have moved and attempted to make ourselves at home, cutting small doors into the large ones so we can come and go without being reminded of our own smallness. As we begin to look closer at the foundation and the way these doors are anchored into the granite, a new and even more startling observation emerges regarding the way the stone itself has been manipulated. The anchoring of these 10-meter bronze valves into the finished granite frames reveals a precision that exceeds the requirements of mere decoration. In the west portal of St. Isaac's Cathedral, the sheer mass of the doors, approximately 20 tons, presents a mechanical challenge that contemporary engineers would approach with caution. To swing such a mass on hinges, the pivot points must be engineered to withstand immense shear stress. Interestingly, these pivot points are not positioned to favor the strength of a team of men pulling from the bottom. They are balanced in a way that suggests a single point of pressure applied much higher than a human shoulder. Logic dictates that if an architect designs a door for a specific user, the ergonomics of opening that door must be prioritized. Yet, in this space, the ergonomics are consistently shifted upward. The physical placement of the door handles and the internal locking mechanisms provides a mathematical paradox. In many instances across these historical structures, the primary pulling rings or latches are situated at a height of 2 to 3 meters. From the perspective of a modern human, this placement is an operational failure. Applying force to a heavy object above one's head is the least efficient way to move it, according to the laws of basic physics. It invites injury and provides the least amount of leverage. If we assume the builders were identical to us in stature, we must then assume they intentionally chose to make their daily lives physically exhausting and mechanically inefficient. It is perhaps more logical to consider that the height of these handles was perfectly aligned with the natural waist height of the intended user, placing their center of gravity in a position to move the bronze valves with ease. This observation extends to the internal, small doors that have been cut into the larger bronze panels. These secondary entrances, which we use today, often appear as crude interruptions of a grander design. They are the only elements of the portal that match the human scale. One must wonder why, if the original intention was to accommodate human passage, the architects did not simply design the primary doors to be manageable. The common explanation of grandeur for the sake of God fails to address the mechanical reality of the lock boxes. Inside the doors of St. Isaac's, the internal gears and bolts are massive, requiring tools of significant size and weight to operate. The keys themselves are not instruments for a pocket, but heavy iron rods that require a two-handed grip for a modern man. Moving from the doors to the stairs that lead to them, the discrepancy in scale becomes even more pronounced. The granite steps of the porticos often exceed the standard ergonomic height for a human stride. Modern building codes, based on centuries of architectural study, suggest a step height of 15 to 18 centimeters for maximum efficiency and safety. The steps at St. Isaac's, and similar, giant, structures, frequently approach 25 to 30 centimeters. While a human can certainly climb them, doing so requires a conscious lifting of the knee that is unnatural for a casual gait. For a person standing 3 or 4 meters tall, however, these steps would provide the exact same, comfortable, rise that we experience in a modern office building. The architecture is not merely large, it is proportional to a different biology. The visual composition of the bronze reliefs on the doors also follows this logic of elevated perspective. The most intricate details, the faces of the saints, and the central themes of the narrative panels are often situated at a level where a human viewer must tilt their head back at an extreme angle to see them. This creates a psychological and physical distance. However, if one imagines an observer whose eyes are level with the center of the door, at roughly 5 meters, the entire artistic composition resolves into a clear, direct line of sight. The sweet spot of the artwork is physically inaccessible to the people who currently inhabit the city. One must also consider the weight and density of the materials used. The columns of the cathedral are monolithic red granite, weighing over 100 tons each. They were moved and raised with a precision that suggests the builders viewed these masses not as impossible burdens, but as standard building blocks. When we look at the doors within this context, we see a consistent theme: the rejection of the human module. In architecture, the module is the basic unit of measurement based on the human body, the reach of an arm, the width of a step, the height of a gaze. St. Isaac's Cathedral ignores the human module entirely. It adheres to a different set of proportions, one where a 10-meter door is not a monument to the impossible, but a functional entrance for a standard inhabitant. The sheer volume of air within the cathedral also serves no practical purpose for a human congregation. The heating and maintenance of such a vast vertical space is a logistical nightmare. In a northern climate like that of St. Petersburg, building a ceiling that reaches 100 meters high is an invitation for heat loss and structural decay. From a thermodynamics perspective, it is irrational. Yet, if the occupants required the headspace to move freely, or if their biology required a larger volume of oxygen and a different rate of air circulation, the dimensions of the cathedral shift from mystical to functional. There is a version of history that suggests these buildings are the remnants of a previous civilizational cycle, one that operated on a different physical scale. This is not necessarily a claim of magic or aliens, but a reflection on the possibility that the human form has not always been the size it is today, or that we share this world with a branch of the genus Homo that has since vanished. The artifacts, the doors, the handles, the steps, and the keys, remain as silent witnesses to a logic that we can no longer fulfill. We inhabit these spaces like children in a house built for adults, modifying the entrances and using only the lowest levels of the vast chambers. These observations are not intended to be a definitive refutation of academic history. They are an invitation to look at the physical world with a sense of analytical doubt. Physics and ergonomics do not lie. They reveal the intentions of the Creator through the utility of the creation. When a handle is placed 3 meters high, it is there to be grabbed. When a step is 30 centimeters tall, it is there to be climbed. The question is not why they built it so big, but for whom they built it so accurately. I do not claim to hold the ultimate truth regarding the origins of St. Isaac's Cathedral, or the giants who might have walked its halls. I am merely sharing reflections based on the clear, physical evidence left in the bronze and stone. The next time you stand before the great west door, look not at the artistry, but at the height of the latch. Consider the weight of the key. Perhaps, in the silence of the granite, you will find your own answers.